We're given this diagram of a wedge. We can see that AC is 10 centimeters long, CE is 20 centimeters long, and the angle BCA is 30 degrees. We're asked to find, to three significant figures, the total surface area of the wedge. The easiest face to begin with is ACED, the base of our wedge. We should be able to see this is a rectangle, and we know both length and width for this rectangle. CE is 20 and AC is 10. Therefore, the area of this base is just going to be the length times the width. So 20 times 10, which is 200 centimeters squared. Note here that this is an exact answer, so we don't need to worry about a number of significant figures. So we need to work out the area of the other faces. We have the two triangular ends, the rectangular back, and the rectangular sloping top face. We're going to need to work out some lengths. We need to work out AB, and I'm going to call that X. We also are going to need to work out BC, which I'm going to call Y. If we draw out the triangle ABC, and this is always a good plan when working with 3D shapes, the right angle is here, this length is 10 centimeters, and this angle is 30 degrees. This is the triangle ABC. This is the length we called X, and this one Y. Here we have our angle. The longest side is always the hypotenuse. For our angle, this would be the adjacent, and this would be the opposite. Let's look at working out X first. Opposite and adjacent. We have so, car, toa, and for A and O we need the tangent. So the tangent of the angle is equal to the opposite divided by the adjacent. Multiplying through by 10 gives x equals 10 times the tangent of 30 degrees, and this calculates to give us that x is equal to 5.7735 centimeters, correct to 5 significant figures. Note I'm storing 5 significant figures since I'm expected to give a final answer to 3 significant figures. Strictly speaking, I only need to keep 4 significant figures, but I'm just playing it safe. Now to work out Y. So, car, toa. For Y, we have the hypotenuse, and we know the adjacent. Note I'm using the adjacent because this was information given to me in a question, rather than using the value of x, which I've just worked out. A and H means car, so the cosine of the angle is equal to the adjacent, which is 10, divided by the hypotenuse, which is y. We've seen this before and know the y and cos 30 swap places, so y is 10 divided by the cosine of 30. Calculating this gives 11.547 centimeters correct to 5 significant figures. Note how we've added the information we just worked out onto the original diagram. We're now in a position to proceed to work out the area for the triangular ends. Note we have the same triangle at both ends. Therefore, if we work out the area of one, we'll have the area for the other as well. So here's the triangle. This is 10 centimeters and this 5.7735. The area of this triangle is going to be a half times the base times the height. Calculating this gives 28.8675. We have two such triangles, one at each end, so therefore we need to do the calculation 2 times 28.8675, which gives us 57.735 centimeters squared. If we now look at the back of the wedge, the rectangle ABDF, which we can see just here, we know that AD is 20 centimeters and AB 5.7735. So the area is 20 times 5.7735, which gives us 115.47 centimeters squared. Finally, we can look at the top face, which is called BCEF. Once again, this is a rectangle, 20 centimeters long and 11.547 centimeters wide. So we have 20 times 11.547. This is equal to 230.94 centimeters squared. So our total area is going to be 200 plus the area of the triangular ends, which is 57.735, plus the back face, 115.47, plus the top face, 230.94. Calculating all of this gives us 604.145, which is 604 centimeters squared, correct to the three significant figures required.